Hi, this is RetroTech Dan. Today, I'm going to be looking at two Commodore 128 boards that were sent in to me for repair. It looks like they've both been worked on before, so I'm going to go and start a visual inspection to see what I'm getting into. So this is the first board, and I've already looked over these a little bit, so some of the things I've noticed, the power switch here it looks like it's in bad shape. There's some of the pads are lifting. In fact, this trace going over here to the rectifier is completely gone. A couple of capacitors missing here. This doesn't look very good. There's some bodge wire here. Not really sure what that's for. It's missing the 556 chip. It is missing the SID chip, but the owner was not sending any SID chips along with these. So over here, looks like a bodge wire on the memory. Looks like all these RAM chips have been replaced. These two do not have sockets, but I'll have to check that out. Okay, well, let's look at the other board. This other board is significantly worse off. There's no power switch. There's no filter. Capacitor's gone. The 4066 chip here is gone. The video chip is gone. There's no crystal here. The Commodore bodge wire is not here. This chip is gone. I think that's a ROM chip, not really sure. No resistor pack, that's gone. It looks like the RAM's been changed in this as well. Also notice that quite a number of these ceramic capacitors are just missing. Just gone. So, yeah. I'm going to start on the other one first, as it's more complete. So, let's go. So here's a close-up view of the power switch. There's a lot of damage here, as you can see, and including that trace going over here to the rectifier. So it's going to be a lot of work to fix that. Okay, so the first thing I'm going to do before I even try to power this on is I'm going to remove the power switch, the rectifier, voltage regulator, this bodge wire, and inspect all the traces and everything. And if there's anything else I need to remove, I'll do that. See if I can repair the traces, figure what's broken, what can be fixed, and probably put in a new switch and probably a new voltage regulator as well. So the pins look pretty bad on there. Yeah, so I'm going to do that, and I'll be right back. Okay, so I removed the power switch and the rectifier, and you see there's some pads that this was gone before, but some pads are gone, traces are broken or missing. It's pretty bad. And then let's go down here a little bit. So yeah, this is where those capacitors go, and the 7812 voltage regulator. It looks pretty bad. So this is the other side. This is where the power switch goes, and once again the rectifier pads are missing. And it looks really bad down here as well. Yep, so there's a lot of traces missing and pads missing here, so there's going to be a lot of bodge work to get the power supply going. Okay, so I've put a new power switch in here, as you can see. Of course, there's no solder on this side over here because this trace is gone and these pads are gone, but put a bodge wire on the other side, which I'll show you in a minute. So if I turn it over, it's not pretty, but that's what it looks like. So here's where the power switch is, and there were a lot of traces that were broken. There's nowhere, nothing to hold the voltage regulator to. Let me get down here and show you that. And it's hard to see with the tape, but basically I had to use the leads of the 7812 to fold them over and solder them to contacts that were a little bit further on the board. Yeah, because they don't. See if I can show that. Yeah, right there. Yeah, because there's just no pads at all for this. So anyway, so now I gotta test it and make sure it works. Okay, so now it's time to start testing the voltages coming into the board and on the regulator. So let's do power it on. And let's see, we should have 5 volts right there. Okay, 4.94. Should have 12 volts right here, DC. And we do. Then we should have 9 volts AC. And we do. All right, it looks good. Now let's see if it works. All right, let's see if we get any video output. And nada. All right, time for some further troubleshooting. Okay, so now I'm checking out the 1 megahertz output from the VIC chip. It looks right. All right, so then now I'm going to check the sync line. And I'm getting a signal there. Let's see, let's bring it up a little bit. Okay, that looks okay. Let's go look at the chroma. Yeah, there's data there. So there must be some other issue. It's not getting to the monitor signal. Okay, so this is the back side of the board where the video connection is, which is right here. And it looks like this has been replaced or worked on or something. There's just a lot of disconnects there. For instance, if I try to do a continuity test between here and here, it doesn't work. Now the exposed trace right here, yeah, I can get a signal there, but nothing there. And then the next one over, nothing there, even though it's, I was able to get it here earlier on this trace. It looks like maybe there's a short right here too. Yeah, because these don't, I can't, but these do. So, so I'm gonna have to fix this now. And here's the bodge wires I did for the video output. Still got to clean the flux and everything off, clean it up, make it look a little better. But now I'm going to test it and see if I get any video out. Okay, let's see if I get anything. I got it going into the RetroTink. So I turn power on. Hey, got something. At least it's getting a signal now, but it still needs some work. Okay, so seeing how there's so much damage on this board, and there had been a lot of rework around with the RAM area, I started looking at the RAM, and sure enough, there are some places where, you know, like here and here, where these are making contact anywhere. And then I did some continuity tests just along all the address lines. And there are definitely some disconnects. There's a disconnect on a couple of them on the CAS lines. So I'm going to go through and do more bodge work and see what we get after that. Due to many traces that I have found broken on this board, I decided to go ahead and ohm out all the address and data lines on all the RAM and ROM chips. And this one was interesting. So The kernel ROM, that's the kernel ROM slot right there with the little microscope is pointing to. And you can see in the microscope, there was a trace cut underneath the socket. And let me zoom in. All right, and so you can see that I guess someone probably used a sharp tool or something to get under there to, I don't know, whatever work they were doing on it. But that second trace, the one closest is working, but it's a little scratched. But that second trace is cut right through. And this definitely won't run without the kernel ROM. So that had to be bodged, and there's a bunch of others too. I'll show you in just a sec. All right, so here's the back of the board with all the bodge work I've done so far for the data and address lines. So this is the RAM area, and there's a few short ones here. That kernel ROM, that's this one right here that I just showed you. And this is the color RAM and character ROM. That was, I think it was the character ROM was disconnected from a few pins. So, and then to run this one up here to there. So we're going to see if this, maybe we can get some life out of this thing. Okay, so let's turn it on again and see if we're getting anywhere. Oh, look at that. That looks good. All right. Let's hook the keyboard up to it and see if we can go 64. All right, so I connected the old keyboard up to it. First, let's turn it off and hold down the Commodore key and see if it goes into 64 mode. And yes, it does. So I imagine typing it will make it go there too. Yes. And there you go. Awesome. All right. Now I'm going to run the diagnostics with the diagnostic cartridge and harness. Shout out to Sven Peterson. This is his harness design. So I'm going to turn on and run it and see everything that passes or fails. Okay, so it's obviously not going to pass the SID test. Control port, that's probably because of the analog test that it needs a SID chip for. And the keyboard, I don't have a keyboard plugged in, so it's open. I'll test the keyboard separately. So, but looks like it's good. All right, before I put a SID chip in this board to test, I want to make sure the socket has the right voltages on it. So I'm going to turn it on. And this right here should be 12 volts. There it is. And this should be 5 volts. 4.94, I'll take that. Okay, let's see if the SID chip works. All right, so the sound worked, but the analog inputs X and Y failed, and this is a spare SID chip I have. So I'm going to test it. I have Chip Tester by E.V. Solomon. This is an excellent device. You check all sorts of Commodore, MOS chips, and other logic chips and that, and I've already set it up to test the SID chip, so I'm going to test it, and sure enough it says that it fails. Oops. Let's do it again. Yep, failed XY. So I'm going to try, I have an arm set here. I'm going to try that and see if that works better. Due to the intermittent nature of the controller port tests, I decided to dig a little deeper. As you can see from the schematic, the analog signals, which are labeled pot AX, AY, and pot BX and BY, they feed into U2, which is a 4066 chip. So looking at U2 on this board, it was in the socket and it wasn't pretty. So I pulled the chip out. And it's in pretty bad shape, and actually the rear side looks worse. A few of the pads are gone on this side. It's going to be more bodge work to get this repaired. So this is the test after the bodge work and a new 4066, and it's still not working. According to the documentation for the diagnostic harness, the tests for the control ports for the pot X and pot Y are tied to 5 volts DC through 110K pull-up resistors. So it got me thinking that there may be an issue with the 5 volt power coming in off of the power supply. I'm using a stock Commodore 128 power supply. So I'm going to check and see if I see any issues with noise or ripple or anything like that. Alright, so let's turn it on here and see what we get. Okay, so that's some noise on here. Wow, it's looking like almost half a volt. That's quite a bit, actually. Okay, so what I'm going to do is I'm going to change over to my bench supply and a separate 9 volt AC supply that I have, and see if that's any better. Alright, so I now have the bench supply and the other 9 volt AC supply hooked up, and yeah, wow, that looks a lot better. Okay, I must have an issue with my stock Commodore 128 power brick. I'm gonna have to look at that, fix it possibly. So okay, let's see if this fixes our analog input issues on the controller ports. Alright, one of the last things I need to try on this is to make sure that the 80 column mode works, so let's give it a go. Yep, okay, that looks good. Alright, I think this thing is done. Alright, so the first one is repaired, and I'm going to stop the video right here, and I'm going to do a part 2 on this board. It has a lot more work that needs to be done to it, so... But this is my first YouTube video. Please go easy on me in the comments. But I plan on doing a lot more repair videos of old systems. And I hope it was entertaining and educational. And thank you for watching. Please like and subscribe. And we'll see you next time.